this is the physical science lesson video for section 7.3, and as always, if you'll subscribe to my channel, you'll have all my videos for the whole year. So this is energy changes in reactions. So we've talked about how to balance equations, we've talked about the different types of reactions, and so now we're going to talk about how does energy play a role in these. So chemical energy is the energy stored in chemical bonds of a substance. So we've talked about potential energy, kinetic energy, heat energy. Well, chemical energy is just another of the many forms of energy. Chemical reactions involve the breaking of chemical bonds in the reactants and the formation of chemical bonds in the products. So when a reaction occurs, bonds are broken and new bonds are formed. In a physical process, of course, no bonds are broken or formed. Okay, in a physical process, there's no change in the substances. So breaking chemical bonds requires energy. So think about if I handed you a pencil and said, I want you to break the pencil. You have to use a little bit of energy to actually break it. Whereas the formation of chemical bonds releases energy. Okay, so to break a bond requires energy. We have to put energy towards it to make the bond break. And the formation of a new bond releases energy because that is a positive, like the new bonds want to form, and so that releases energy. In a chemical reaction, energy is either released or absorbed. So it could release energy, it could absorb energy, it just depends on what type of reaction is occurring. A chemical reaction that releases energy to its surroundings is called an exothermic reaction. So think of exo as exiting. So energy is exiting the reaction if it releases energy. In exothermic reactions, the energy released as the products form is greater than the energy required to break the bonds of the reactants. So this right here shows how energy is changing as a reaction occurs. So here we have the energy of our reactants. They always have to make it over what we call our activation energy. That's the energy required to get the reaction going. So for a minute, they get higher in energy, but then if you look, our products are much lower than in energy. So if we went from here to here, where did that energy go? Because it can't be destroyed, well, it was released to the surroundings. A chemical reaction that absorbs energy from the surroundings is called an endothermic reaction. So think of endo as in. Energy is coming into the reaction. In an endothermic reaction, more energy is required to break the bonds in the reactants than is released by the formation of the products. So here we have reactants at the very bottom. Remember, we talked about it's got to get over that activation energy, but our products are much higher in energy. So we went from low energy to high energy, so that means that reaction had to absorb energy as it was progressing. So, we've talked about this before. Law of conservation of energy states that energy is neither created nor destroyed in chemical or physical processes. But remember, we know it can change forms. It can change forms. So, section assessment. What happens to chemical bonds as a chemical reaction occurs? Well, old bonds are broken, new bonds are formed. Old bonds are broken, new bonds are formed. So number 2, how do chemical reactions involve energy? Well, they either absorb or, just hit my necklace up in my face. They either absorb or release energy. They either absorb or release energy. Number 3, is the combustion of propane endothermic or exothermic? Well, if you remember from our previous video, combustion reactions tend to produce a lot of light and heat. So if it's producing heat, that means it's releasing heat. So it would be exothermic. Okay, if heat is a product, that means the reaction is releasing heat, so that would be exothermic. Number 4, is energy created during an exothermic reaction? Explain. Well, we know exothermic releases heat, but energy is not actually created to be released. It comes from the chemical energy in the bonds. Okay, so the energy comes from stored chemical energy within the bonds. It's not actually created, it's just changing form from chemical energy that's stored in the bonds into heat energy that's released to the surroundings. What bonds are broken when one molecule of methane reacts with 2 molecules of oxygen in the following reaction? Well, let's look. We have CH4, so here C is bonded to H, and we have O2, so O is bonded to O. Well, here we have CO2, so C is bonded to O, and H2O, so H is bonded to O. So which bonds are broken? The CH bonds are broken, and the OO bonds are broken. Okay, the CH bonds are broken, and the OO bonds are broken. Alright, so hopefully now you understand a little bit more about energy and chemical reactions and what the difference in exothermic and endothermic is.